So in first year you learn how many physics courses and how many chemistry courses?
There were 2 physics courses and 1 chemistry.
2 physics and 1 chemistry.
Like in first semester we had 1 and second semester also we had 1 physics. And
Okay, okay,
chemistry only in first.
okay. So in physics, what you learn in the first semester, mechanics, dynamics, and the second semester electrodynamics, Maxwell equations, and all this. What you learn?
First was about quantum mechanics
Ah,
and second sem was on electrodynamics.
okay. What was the textbooks?
In first sem we were asked to follow DJ Griffith for quantum.
Griffith is not quantum. It's a electrodynamics book.
It
No, sir,
has
DJ Griffith is a quantum also.
Okay.
the both semesters are DJ Griffith only. In first it was
Yeah.
for
Okay.
quantum mechanics and in second it was for electrodynamics.
Okay. I don't know. Like quantum mechanics, his book is not famous. Maybe.
He has
Maybe.
written 3 books on different.
Okay. Okay, good, good. And chemistry, what you learn in chemistry? Organic chemistry, no,
It was basically about complex
mm,
compounds.
oh, and you have, okay, you don't have lab now. So complex compounds like a coordination compound that you
Yes,
learn
yes,
in.
and in organic we had same type of thing.
Okay, okay. Okay, I think we should start. Very few students has joined. I don't know why. Maybe they are busy with something else. That's okay. You can always refer to the video lectures whenever you need. That is the advantage of this kind of lecture. So in the last class, we were discussing, so we are discussing, so first initially in the few classes, we discussed the introductory things, Reynolds transport theorem, and then we are discussing dimensional analysis. And maybe this class and the next class, we will finish this dimensional analysis. Then we will go for similitude studies, and then we will go for pi flow. So we were discussing some important points about the pi theorem, and we said different points in the last class. One important thing that we were discussing towards the end of the class, that is uniqueness of pi theorem. So we will discuss this uniqueness of pi terms. What this means is, now if you have a problem, there is not a single set of pi terms. You can have a different set of pi terms for same problem, but final result will be same. Either you analyze using one set of pi term, or you analyze the same problem using other set of pi terms, final result will be same. Only the interpretation and the way you are analyzing the problem is different. For example, if you consider the pi flow problem, this is your section 1, this is your section 2, and these things are given, and the velocity is v, by which this flow is taking place inside this pipe. So we have analyzed this problem for delta PL using diameter, velocity, and rho as repeating variable. So if I consider this as repeating variable, and then we have analyzed, and then we found this term delta PL ds square divided by rho vs square is equals to function of some pi term, and this case pi term is a Reynolds number, rho Vd by mu. Now this is one pi term, pi 1, and this is the second pi term, pi 2. Now what if we consider repeating variable as dv mu, and then we'll see. So what if we had selected dv and mu as the repeating variable, So this means You are free to choose repeating variables. So what happens if I choose these repeating variable? Once again, I can do the exercise and I can get the corresponding expression. So I will do fast. In this case, I can write pi1 is equals to delta PL, diameter, velocity, and viscosity. Now if you equate, so this is the first term, and this is FL minus 3, L raised to the power A, LT minus 1 raised to the power B, FL minus 2TC. Now from here, if you equate the exponent, 1 plus is equals to 0, and this is for F. So from here you will find C is equals to minus 1, and then you can have minus 3 plus A plus B minus 2C is equals to 0, and this is for L. Similarly, you can write minus B plus is equals to 0, and this is for T. So now if you solve all this, you can find the value of A, B, C, and from here you will find B is equals to minus 1 and C is equals to minus 1. And A is equals to, you will find 2. You can do this check yourself. Just put this value in any equation and see whether this is true or not. So I have these values, so simply I have written here. So these are the values. Now this case I can write pi term delta PL and d square, that is exponent A is 2, V minus 1, and viscosity minus 1, exponent minus 1. So delta PL d square divided by V times mu. So this is my pi term. Similarly, you can find pi 2 in this case again, and then we will find pi 2 is again Reynolds number rho V d by mu. Then you can write this expression, because you know pi 1 and pi 2, you can write expression. So you can write pi 1 as some function phi 1 times pi 2, pi 1 as a function of pi 2. So you can write basically here delta PL d square divided by V mu, and this is phi 1 and this is rho V d by mu. So the same problem we have solved using two ways. One, in that case you have different repeating variable. So the first solution was, if you remember, the first solution was delta PL. If you have your notebook, you can check this. And then rho V square, this is some function phi, rho V d by mu. So this was the first solution. And this is the second solution. Same problem, if you choose different repeating variable, you will have different pi terms. Now, finally, if you plot, you will get the same answer. For example, if you consider the first set of solution, that is this one, on the x-axis you plot rho V d by mu, on the y-axis you plot delta PL d divided by rho V square, and you perform the experiment. So you change the x variable, this side on the x-axis whatever you have, and you measure the y thing, by whatever you have on the y-axis. So if you do this experiment, you will get different points. Maybe something like this, you will get different points. And if you combine these points, you will get the curve. Similarly, if you are using the second set of repeating variable, once again, you can plot on the x-axis rho V d by mu. This means you are changing either the velocity or the diameter or the viscosity or the density or a combination of two. Generally, we change the velocity because it is easy to control the flow inside the pipe. It's difficult to change the density and diameter of the pipe because every time in the experiment you have to change the diameter, you have to bring a new pipe. And that's why this whole idea of dimensional analysis. That is, we are trying to simplify the problem. On the y-axis, we can plot this term, that is delta PL ds squared divided by b mu. Now in this case, if you plot this, once again you will have, so you are doing the experiment, getting the points, connecting them, finding this equation of curve. In this case, you will find a different curve. This means this is a function phi, this time this is a function phi1. So phi and phi1 will be different, but once you know this Reynolds number, you can go on this axis and you can find delta PL. Similarly, if you know Reynolds number, you can go here and you can find delta PL. So the final result is same. Either you use one set of repeating variable or you use another set of repeating variable. Finally, you will have the same pressure gradient. So I can say both equations, that is the two equations that we have shown, are correct. So we can say both equations are correct. However, the function phi and phi1 are different. The function phi and phi1 will be different since the pi terms are different. Why this is so? Because since the pi terms are different. Pi terms are different. So you will have different set of pi terms, you will have different functions. So what is the conclusion? Conclusion is there is not a unique set of pi terms that arises from dimensional analysis. However, the required number of pi terms are fixed. So for a given problem, how many pi terms you will have, that is fixed. But which pi term you will take, that will be different. So I can conclude that there is not a unique set of pi terms that arises from dimensional analysis. So from dimensional analysis, you can have a different set of pi term, and this can also be seen. For example, if you have a pi 1, you use pi 2 and pi 3 as a pi terms, you can have something like this. But from this two, you can always develop, or you can always frame a new set of pi term. For example, you can frame pi 2 dash. How you can do that? You can simply take pi 2 raised to the power a, pi 3 raised to the power b, because these are dimensionless. This is also dimensionless. So that's why you have multiple possibilities. So pi 2 dash is also a pi term, which is a combination of pi 2 and pi 3. So in that case, what you will do is you can write the same problem. You can solve the same problem. Pi 1 is equals to phi 1 new function, pi 2 dash and pi 3. So you are taking a different pi term, pi 2 dash. That is not same as pi 2. So this is also a solution. This is also a solution. Or you can also have a solution something like this, pi 1 and this function phi 2, and then you can take pi 2 and pi 2 dash. So this is also a solution. You see, in all cases we are using 3 pi terms. That is, the number of pi terms is fixed, but we have different pi terms. Number is fixed, and since different pi terms we are using, that's why these function phi, phi 1 and phi 2 are different function, are different. Makes sense? For example, if you consider the previous problem, in that case you have delta PL d by rho v square, and this is phi rho v d by mu. So this was the previous problem. We can call this as a phi is equals to pi 1 is equals to phi as a function of pi 2. We also solved the same problem, and in that case we said we can also express this problem something like this, and phi 1 rho Vd by mu. This is the same thing that we solved in the previous page or just before this discussion. So I can call this a new pi term. Pi 3 is equals to some new function phi 1, and this is same. So this is a function of pi 2. So you can say this is pi 1 and this is pi 3. If you see closely, you will find pi 3 is equals to pi 1 times pi 2. What is pi 1? This term is pi 1. Rho delta PL by rho v square times d. So this is pi 1. What is pi 2? So this term, Reynolds number, rho v d by mu, this is your pi term. So from here you can see rho cancels out and 1b cancels out, and then you will find this, if you simplify this, you will have delta PL ds square by mu times d. And this is nothing but your pi 3, you check here. So this is your pi 3, delta PL ds square by b mu. So that is your pi 3. So you see, you can have two steps. So what we are doing is one set of pi term bars in the first case, pi 1 and pi 2 is first set of solution. And the second set of solution is pi 3 and pi 2. In both cases, we are using two pi terms. But we can derive one pi term in one set using the other set. And in this case, you can see pi 3 and pi 3, pi 1, pi 2 are related. So there is no unique set of pi term. You can have a different pi sets, and all basically express the same problem. You can find the solution either using any set of pi terms. I hope this is clear. If you have anything, then you can ask. Otherwise, we can proceed to the next part, that is determination of pi terms by inspection. So we said we can find pi terms using dimensional analysis, and then you can frame the whole this pi theorem we can perform, and we can frame the expression. There is another way by which you can find the pi terms, and that is simply by inspection. Can anybody will say what is the meaning of this term, that is finding the pi terms by inspection? So let us have some discussion. Anyone wants to say how we will find pi terms using inspection? So I am saying
hit and trial method.
So what you will do in hit and trial method?
We can try to find combinations that will be dimensionless.
Yes, you are right. Anyone else want to? You see, all these are just common sense, nothing new. Like it's not a mathematics or science. All common sense. You have to, you have to interact. Good. Anyone else want to say something? What do you understand by just simply by inspection we can find the pi terms? Anyone wants to interact? Okay, good. So what we can do is we can use one way to find pi terms is a method of a repeating variable, and that is forming the equating the coefficients. Another is using inspection. What are the important points that you have to remember? That is, your pi terms should be correct in number. That is, you cannot have more than required. And another thing is your pi term is dimensionless. So these are dimensionless. And another important point that these pi terms are independent. So when you are doing method of inspection, you have to keep this in mind, and then you can simply find the pi terms by inspection. So let us try to illustrate this. For the previous problem, water flowing in a pipe, what are the things that is given? V rho d mu, and we are interested to find pressure gradient delta PL. And as we said earlier also, delta PL is a function of d, rho, mu and V. And we know that first step we write all the dimension FL minus 3 DL, and dimension of rho is FL minus 4 T square. Dimension of mu is FL minus 2 and T, and V is LT minus 1. So now in this case we have 5 variable. So there are total 5 5 variable, and we have used 3 reference dimension, and that is also my basic dimension in this case. 3 reference dimension, and then this means I need 2 pi terms. So 2 pi terms are needed. Now I will try to find these pi terms simply by inspection. And sometimes this is easy because when you use inspection method, it is fast and it also gives you physical meaning. It's a significance. Or you have a feel for the problem. And that's why this method is more intuitive than rather just doing algebraic method. That does not gives you physical meaning, or you are not involved in the problem. But when you do this method, inspection method, you are involved in the problem, and that gives you better significance or better idea. For example, what we will do is delta PL. So let us find first pi term. So delta PL has FL minus 3. I want to cancel F first. So what I will do is I will divide by rho. So just I am trying by inspection. So if I divide by rho, FL minus 3, FL minus 4 and T square. So this will give you L divided by T square. This basically cancels F. So one dimension you have removed from this. So what is your target? Your target is to find a dimensionless quantity. That is the pi term. Now next what we can do is we can divide by V square. So let us divide by V square. Divide by V square. So I can have delta PL divided by rho V square. So this has a dimension L T raised to the power 2, and this will be T square divided by L square. Now I will cancel T. So we are trying to cancel one at a time. So now this cancels T. So I will have 1 by L. So this cancels T. Now next time we will try to cancel L. So certainly we have to multiply by something dimension of length. So let us multiply by D. So this multiply by D. So in this case, if you multiply by D, you will have delta PL rho V square, and then multiply by D. You will have, so these all are dimension. These all are dimension. Yeah, so this is dimension of 1 by L times L. So there is no dimension on the length. So this is my pi term. So I have a dimensionless quantity, and that is delta PL D divided by rho V square. So in this problem, we have to find 2 pi terms. 1 pi terms will be just found by using the inspection. What was the idea? First, I want to cancel 1 term, second term, and then finally the third reference dimension. Now we can find the second pi term, that variable that has been not in used in the pi 1. Viscosity has not been used in the pi 1. So we will consider viscosity because I have to include all the variables. So I will use viscosity, and including that viscosity, we will find the second pi term. So let us find the second pi term. Second pi term. So we are interested to find second pi term using viscosity. Viscosity, that is nu. So what I will do is, first I will divide nu by rho. So this is FL minus 2T, and then FL minus 4T. So this is 1 L raised to power minus 2 and T. So what is cancelling? So in this case now there is no F. So reference dimension F has been removed. Now once again divide by B. You will see that time dimension is gone. So this is, if you divide 1 by Ls minus 2, and this is Lt minus 1. So this you will have L minus 1. Now you multiply rho B D, because I have to eliminate D length dimension, multiply by D in the denominator. 1 by L raised to the power minus 1, length L. So this is again L raised to the power 0. So this is my pi 2 term. So this is a dimensionless quantity, that is mu divided by rho Vd, and reverse of this number is Reynolds number. So now you know the pi 1 and pi 2, you can express your answer or your final expression. This divided by rho V square, some function phi, and this divided by mu divided by rho Vd. So this is your final expression. As I said earlier, there is no unique set of pi terms. Every time you perform, you will have different pi terms, but the final expression, final result you will get will be same, because once you do the experiment, your function will change, but your function will change, but the final result will be same. So these are the ways by which you can basically calculate the pi terms. So there are two ways by which you can formulate the pi terms. One is using the method of a repeating variable, pi theorem, dimensionless, whatever the name you want to give. And the second is you can use method of inspection. Method of inspection is relatively quick, also gives idea, because once you know these are the numbers, different numbers that are dimensionless numbers, so you try those numbers and then you can find the different pi terms. So you see, we have introduced some pi terms, some dimensionless number. So in fluid mechanics, there are many dimensionless numbers. One dimensionless number that we know, that is the Reynolds number. So there are many dimensionless group in fluid mechanics. So common, so we'll discuss one or two or maybe three common dimensionless group in fluid mechanics. So if you see, there are different functional, different dimensionless group. You can say this is a pi terms. One is Reynolds number, rho V L by mu. So this is your Reynolds number. Reynolds number is basically ratio of inertia force to the viscous force. So basically, sometimes this is simply written as Reynolds RE. Reynolds number is nothing but this is the ratio of inertia force to the viscous force. Another number that we have, that is called Froude number. FR, so FROUDE, Froude number or Froude number. So this number is equals to V divided by under root ZL, and this is the ratio of inertia force and divided by gravitational force. We'll discuss more. So so we are just listing some of the numbers. One is the Reynolds number, another is Froude number. We also have something called Euler number, Euler number, and this is equals to pressure divided by rho V square. This is the ratio of, so basically these are the ratio, all the numbers are ratios. So this is pressure force divided by inertia force. Pressure force divided by inertia force. So there are a large number of dimensionless groups that we use in fluid mechanics. I will show you some of them. So there is a list of dimensionless groups, and that is given in this table. So you see, this number is called Reynolds number. This is inertia force to the viscous force, and generally of importance in all type of fluid dynamics problems. Froude number, Vy under root ZL, inertia force divided by gravitational force. When this number is applicable, flow with a free surface, and mostly where you have gravitation, that is important, or the fluid is experiencing some gravitational force, in that case you can use Froude number. Euler number, pressure divided by rho V square, that is pressure force divided by inertia force. Problems in which pressure or pressure difference are of interest. This number, you will see this number. So now you see, once you have idea of this number, then whenever you are analyzing a physical or real problem, then you will know which number I should use, which pi term I should be looking for. For example, if I have a problem that has gravitational force, then I will look for a pi term related to the Froude number. And if I see some viscous terms are there, viscosity is involved in the problem, then I should go for the Reynolds number. Similarly, if I have a pressure difference, then I should go for the Euler number. So these are the different numbers that you should know. So there are different numbers that we have, and these dimensionless numbers or dimensionless groups are important pi terms, and that can be used to derive pi terms quickly. So what are the physical significance of this dimensionless group? So we will try to just illustrate one. So so from where this is coming, so physical meaning of dimensionless group or number, you can say dimensionless group. So what is the physical significance? If you remember, in the first class we showed you a streamline, and we said this is a fluid particle moving along the streamline. So this is a fluid particle moving along a streamline, moving along a streamline. So inertia forces Fi, that is inertia force, this is equals to mass into acceleration, and acceleration along the streamline. So AS denotes acceleration along the streamline, along the streamline. So if you remember, by the change of variable, I can also write acceleration something like this, that is Vs dVs by dt, We showed in the previous class, nothing fancy, you know already. So now what we want to do is we want to write velocity and displacement in terms of a dimensionless form. So what we can do is we can writing Vs and S in dimensionless form. Dimensionless form. So what we can do is we can define a characteristic velocity Vs star, and that is nothing but velocity divided by V. So no, sorry. So this is V. This is not the characteristic velocity. This is the characteristic velocity. So what we are doing is we are dividing the velocity with a characteristic velocity. So this velocity is characteristic velocity. So we are dividing Vs by some characteristic velocity and we are getting a dimensionless number. We are writing Vs star, but this is a dimensionless number because we have already divided the velocity with the characteristic velocity. Similarly, I can divide S with some characteristic length L. So this is my characteristic length. So this is my characteristic length. I'm not writing. So this is the characteristic length. Now, if I plug these two into the equation, so AS is equals to what? AS is equals to Vs dV. So what was AS? Vs dVs dt. So what is Vs? So this will be so this is Vs is equals to Vs times V. So this is Vs star times V. I think maybe let me check. Okay. So let us plug it here. So Vs star times V and dVs. We also have length. So we have change of variable. So what was that? Vs dVs. So okay. So AS will be, so I have something different here and that's why I'm just waiting. So okay, in terms of S.
Sir, instead of dt, we should be writing
Yeah,
ds.
you're right. So whereas relation is dV by dt and ds. So you should have told me earlier, you know. So this is ds, yeah. So that's right. Good. So this is, there is a mistake in writing. So this is ds. So now can you plug this here and then this is just a star. Yeah, so this will be if you plug, so AS is equals to Vs dVs ds. So let us plug this. Vs is equals to nothing but Vs star times V, Vs star times V, and then dVs. So Vs is nothing but Vs star times V, and this divided by ds. S is nothing but S star times L. So this becomes, this will be Vs square and then Vs star. Take this V outside of the integration. Then this is Vs star and then you will have dVs star and this will be ds star. L will come outside. I hope this is okay. Now Vs square by L, Vs star dVs star divided by ds star. So what we have done is we have simply changed the variable and we defined a new variable S star and Vs star by dividing by the characteristic velocity. So now my acceleration is this. So you see, there is a term that is V squared divided by L. So now I can find inertia force Fi is equals to m times acceleration. Acceleration is V squared by L, Vs star and dVs star divided by ds star. And let's say, so this is the inertia force. Let us find the gravitational force. So weight of particle, fluid particle, this will be equals to m times z. So we can, now this is the gravitational force mz. So we can find a ratio of inertia force to the gravitational force. Fi divided by fz, this is equals to, so if you take this all, so m cancels out, so I'm directly writing the final answer. So this will be Vs squared divided by ZL, m cancels and you will have Vs star, dVs star divided by ds star. Same problem. Now what is this number? So is this has a dimension or this is a dimensionless term? Is this as a dimension or this is a dimensionless?
The dimensionless.
So what this called? This number is called, what this number is called?
For fruit number square. Square of fruit number.
Fruit number. So this is square of fruit number. So this is your square of fruit number. So you see from where this number is coming. So we are, so if I try to, so what was the idea? Idea was we want to look from where these numbers are coming and what is the significance. For that purpose, what we did is we considered a simple fluid particle and we calculated the inertia force and gravitational force on that fluid particle. And once we take the ratio, we have some dimensions, we basically formalize in terms of dimensionless everything. Then we are getting a number that is a dimensionless number, and then we are calling this number as a fruit number, a square of the fruit number. So fruit number is nothing but V under root ZL. So now see, if my fruit number is high, so this number is high. If this number is high, in that case, what will happen? This ratio will be high. This means gravitational force will be a small, inertia force will be high. So in other words, I can say what this fruit number is telling. This fruit number is telling whether should I neglect the gravitational force or not. Similarly, in other situation, you will see whether should I, if you have Reynolds number, whether should you include the viscous force or not. So these numbers have some physical significance or have a background of mathematics, and it tells which force I should include in the problem and which force I can neglect. So now I can say fruit number is a measure of the relative importance of the inertial force acting on the fluid particle to the weight of the particle. So you can basically find in which situation you have to include this. So in problem where gravity is not important, you will not consider the fruit number because it contains a term, it contains a pi term that has a z. If you see, the fruit number is not equal to the force ratio. Basically, it is some kind of measure. So fruit number is not ratio of this force. Fruit number is multiplied by this term is the ratio. So fluid number is not exactly, if I say fluid number is a ratio of inertia to gravitational force, that will be wrong a statement because it's also multiplied by some other term. So better to say that fluid number is a measure of, or somehow it is related to the ratio of forces. It's not exact measure, it's a related. So I can say this is not the exact ratio, but somehow it is related or it is proportional. So this is the meaning of fluid number. So next number we have, that is Reynolds number. And this is used to distinguish between laminar flow and turbulent flow. So this is RE, often written as, and this is the length dimensions. If you have a pipe, then you can use diameter D, rho v d by mu. And this is used to distinguish between laminar flow and turbulent flow. So maybe we will discuss a little bit later what is the meaning of turbulent flow. For the time being, I am assuming that you understand what is laminar flow. So if you have this ratio, Reynolds number is much less than 1, then you can say viscous forces are dominant because mu term is very high in that case. So I can say viscous forces are dominant. Now Reynolds number is much greater than 1. In this case, this force are small. Viscous forces are small. And you can neglect that if you want. Similarly, Euler number, that is also important sometime. So Euler number is written as pressure divided by rho v square. This is pressure force by inertia force. You have a Mach number, Cauchy number that I showed earlier. So these are 4-5 numbers. You should be knowing what are the ratio for these two forces, this number, where these kind of number is implied or used, what is the application of these numbers. Now next we will discuss how this pi term. So we have discussed how to form and find the pi terms, but we have not said much about the function, and that is found from the experimental data. So once you have the pi term, then you go into the laboratory, do experiment, plot, and then you get the function form. So we will try to illustrate using 1 or 2 cases how you find or how you do correlate whatever you have learned, the pi terms, with the experimental data. So correlation of experimental data. So how do you find basically the pi term? And this we will, so you can have a 1 pi term, you can have a 2 pi term. For example, the simplest problem will be 1 pi term. For example, you have only 1 pi term. This means in problem you have only 1 pi term, pi 1. And then the simplest situation can be the pi 1, and this pi 1, there is no another pi term this side. So there is nothing inside this. This means this has to be constant. So the simplest problem that you can have is only 1 pi term. In that case, pi 1 will be constant. So this is the simplest situation that you can have, and that for this purpose you can perform the experiment, and you can find the value of this constant. So you can have the simplest situation, only 1 pi term, and in this case this will be equals to constant. And fortunately you have already studied this in your physics courses. If you remember the drag force on a sphere, what was that value? Can anybody tell me? If we have a sphere and it is immersed into a liquid of density rho, viscosity mu, diameter of a sphere is given. What was the drag force? Elementary physics. Anyone? How come? You have to tell me. Am I audible?
6 pi eta RV.
Good. Anyone else want to say something whether this is right or wrong? Yeah, so you have this 6 pi, whatever the value, eta, in this case we will use mu, not eta. So this expression we can derive using dimensionless analysis. That is the simplest thing. So if you have a sphere, and on this sphere we have a drag force, let's say if it is going in the downward direction, then drag force will act in the upward direction. Drag force acts always opposite to the velocity direction. So this is a sphere, so the drag force will be a function. So from experience we know that this drag force will be a function of diameter of this sphere, velocity by which this sphere is falling, and viscosity of the liquid or air or fluid in which this sphere is falling. So now I know drag force is a function of dv and mu, and then I can find using the pi theorem, or you can use method of inspection, you can find the pi terms. I think we should stop here, and the next class I will discuss this, and then we will discuss about the similitudes. If you have anything or any question, then you can discuss, otherwise you can log out. So we will meet tomorrow at 11 o'clock. Any question?
No, sir.
Okay. Okay, if you don't have any question, then we can stop here, and I will try to put some problems also maybe tomorrow, and you can do at your own, and then we can discuss more. Okay, see you tomorrow.